Good morning, everyone. So we're back with another LeetCode question. So that's today's question. That is 1457. Pseudo-palindromic path in a binary tree. Let's read the question statement. And the question statement says, given a binary tree where a node value are digits from 1 to 9, a path in a binary tree is said to be pseudo-palindromic if at least one permutation of the node value in the path is a palindrome. Return the number of pseudo-palindromic path going from the root node to leaf node. Okay, so yeah, so yes, we have to return a path in which the elements coming into the path are going to make a palindromic number when combined. Okay, and it does not have to be any sequence. We can rearrange the numbers. That means any permutation of the elements coming in the path, any one of the permutation should make a palindrome number. So yeah, it's easy because we just have to first you have to count, you have to get the count of all the elements in the path, and then we have to see that only one element should have an odd count and every element should have even count, or all either one case is the first case that all the elements should be even counts, or in second case we can allow only one element to be in odd counts. So yeah, that's what we are going to do. The reason we are doing it, that to construct a palindromic number, what we need is, if we want a number here, we also want a number in this side from the center, right? If that's the center, and like if we are putting one here, then we also need one here, and if we are putting three here, we also need a three here. Similarly, if we are putting 5, we also need 5. Okay, so if we need one more time, then we are going to need one again. And the only time we are not going to be needing a pair of number is when we are putting the number in the center. We can put only one number in the center, and that can be any number like 4. So as you can see here, 4 can be a single count or an odd count, but rest of the number rather than 4 need to be in even count. Let's turn to the question. So how we are going to do? So first off, we are going to run a recursive function. That function will be keeping the count of all the numbers in the path of the function. So that's what we can do here. Okay, so we are going to be keeping a dictionary here. Yeah, or rather we can just have an array. Yeah, because our numbers are from 1 to n, then we can have we can carry an array in our recursive function. That array will be having 9 elements, and it will be keeping the count of all the 1 to 9 1 to 9 elements. Okay, so let's jump to the code, and first off we need the function. Let's call it fun. And what are we going to need here? We are going to need the current node, CNODE, current node. That means current which node we are there, and we are going to need the count array. Let's name it CT array. And what else do we need here? I think that's enough. Do we need anything else? Yes, no, I don't think we need anything else. Or do we? Do we need anything else? No, I don't think we need anything else. Okay, so let's jump right inside the function. So what do we have to do here? So we can do here is that first we need an AND case, that is going to be if the current node is equals to that means current node is the leaf node, that means it's it's nothing. Then what we will be needing here, we can't just operate on this node, or we can do it, yeah, we will return 0. How does that sound? Yeah. Yeah. And we now will be calling the branches. So we'll be calling the branches if the current node dot left is equals to none, and c dot right, or it's just right, that's just right, is equals to, if these two things are none, then what do we need here? Then we are going to call the operation that now we are at the endpoint. So here now what we'll be doing here, we'll be checking if these conditions satisfy, that all the numbers are in even and only one number is in count, not more than one number is in odd count, and all the numbers are in even count. So for a in array, ct array, count array, okay, we are going to go through all the numbers, and if c a is an odd number, then we will count 1. And the moment we find that if ct is greater than 1, the moment we find that has been increased from 1, the moment we find that, we'll be returning 0, because we cannot operate on this one, so we'll be returning 0. And if we see that yes, if we see that the for loop has gone through properly, that means we didn't find any time where ct was greater than 1. At that point we'll be returning, what should we return? Any guess? Yeah, we should be returning 1. Okay, what do we have to return if at least one combination of the node is path is a palindrome? Okay, return the number of pseudo-palindromic. Okay, so we have to return the number of pseudo-palindromic paths, right? So here we are going to return only one, such that we can count one for this leaf node. That means every leaf node contains a path from the root. So at every leaf node we have to return a value, either 0 or 1, either to count that value or to leave that value. Yeah, so if we see that the odd count has gone up even from 1, then we can straight away return 0. And if we see that the count doesn't go beyond 1, then yeah, if we see that the count doesn't go beyond 1, then we'll be returning 1. And that's it. And if we find any, you know, no, any null node, it can, for like in this case here, we cannot call this one as a leaf node because it has only one node which is null, and the other one, it has one branch, so we can call this one as a leaf node because it has both the branches as null. That's why we can only operate on this condition. We can't operate on this condition. You need both the conditions to be none. And here I have written the spelling of none wrong. Sorry, that was my cat mention. And now here, what do we need to do is we need to just call out this function. So yeah, we need to call this function, and I think we're missing out on something, or what? Yeah, I think we are definitely missing out. And that is, if it's not a leaf node, then what? Yeah, we have to call function, right? So if it is not a leaf node, then we need to call the function. We need to return we can do it like that. Let a equals to be one branch, and that is going to be function of root dot left. That is going to be our current node. Current node C. Current node, the name is, I mean this one, current node dot left, and what is going to be our current array. So our current array needs to be copied here, so we'll make a copy of it. And how do we make the copy? By doing this. Our current array has been copied, and yeah, this is going to be a, and b is equals to same thing, just a slight change. That's going to be right. And here what we will be returning, a plus b. Okay, so this is what we're going to return, and here we just need to call, or we just need to return function root node and array that is going to be empty. Okay, no, we can't return an empty, we can't put an empty array. It should be like this. Then will it work like this? Let's see. Let's try to run it. Okay, C node is not defined. We have defined C node, right? I see. I put a capital C there, that's why. Let's see what happens. Okay, CT array is not defined. Where is it? CTR, and the A is capital. Small syntax printing mistakes. Syntax error. Yeah. So we do have an error. I mean, we have wrong answers here. Okay. Okay, so if we are having wrong answer, then what's the reason for that? Hmm, I don't think it's here. I don't think is there something wrong here. No, there's nothing wrong here. Something is wrong, and now I know what's wrong here. Thing that's wrong here is at this point we also need to increase the count of the current node's value, which we are not doing. So array, sorry, array c dot val. So yeah, we also have to increase the count of the current node, right? Which we are not doing. So we are actually not increasing the count of any element, because if we don't increase the count at the current node, that means we are always going to get an zero array. I mean, array only contains zero, or current array will contain only zeros, so that will return one in all the all the leaf nodes. That's why we are always getting answer which is always greater than the expected answer. Let's try to run it again. So here we are getting, we're passing all these three test cases. Now let's try to submit this. Yeah, we do have a successful submission, and I think I consider this a good submission because we are near to the fastest solutions. Okay. Yeah, thank you for watching.